Hello everyone, in this video I'm going to introduce you to CDK or Cloud Development Kit, and we're going to learn all about CDK by creating and deploying a practical project that leverages both Lambda and SQS as an event source, and we're going to deploy that into the AWS cloud. And also as part of this project, we're going to walk through the AWS console to take a look at some of the different resources that we created as part of our CDK code. So if you're new to CDK, then this is a very good video for you because this is going to be just a kind of end-to-end introduction on all the different commands that are at your disposal, the file structure that you get by initializing a CDK app, and everything in between. So I do encourage you to follow along because I do think that it is the best way to learn, especially if this is your first time interacting with CDK. And I'm going to be going kind of a little bit slow just to make sure that everyone is on the same page and recapping things as we go along. So a couple of requirements that we need to have set up before we can get started. So there's three, in fact. So the first is the AWS CLI. If you don't have that installed or you're not sure, you can just type into your terminal AWS to see if everything is there. We just get an error here and that's totally fine. So everything is working. You also need CDK. So CDK, of course, is Cloud Development Kit. It's going to be what we're using to create and deploy all our resources. Just going to press enter here and you can actually check the version as well. So CDK -- version. I am on version 2.91.0. If you're on the older version of CDK, which is version 1.0, you definitely want to upgrade because they did change a bunch of the syntax. So if you're on that version, then you may not be able to follow along successfully. And the third dependency, the third thing that we need is pip. And you can just type in pip to make sure that you have it installed, and you can see that we have it here. So everything is good to go. Okay, so there's a couple ways to get started with CDK, and there's some ways that I encourage and other ways that I discourage. So you can see here that I have a completely empty folder here. It's just called, if we can actually see the name here, SQS Lambda Demo. So the way that I suggest to get started is to create a kind of sample application and then change the sample application to your liking to do basically whatever you want to do. You can also just create all these files manually one by one. I highly discourage this approach because more often than not, you're going to make some trivial error. It's going to make you want to pull your hair out. So what I suggest to do is just to get started with a sample app, which is what we are going to do here. So I'm going to go into my terminal, and I'm on a Windows machine, but this should also apply if you're on a Mac or a Linux box or whatever. It's all the same stuff, assuming you have all the dependencies installed. So we're going to use this CDK command. So we're going to type in CDK init, and we're going to create a sample-app. And we are going to specify the language as being Python. Now, CDK also supports other languages as well. So there's Java, there's C#, there's, I believe, Ruby as well. There's like a bunch of different languages that are supported here. TypeScript is another really popular one. And so you can select whatever you want, but we're going to be doing this with Python in this example. And by using the sample app, this is kind of a pre-constructed project that is going to have some sensible defaults where you can learn about the folder structure, the different files that are at play, and basically what's going on with CDK. So let's press enter here, and this is going to do some things. And as you can see already, a bunch of stuff already popped up on the left-hand side here, and it's just basically creating a virtual environment right now. And just as a reminder, we create virtual environments so that when we install things, they are local to this project and not in the global namespace. So sometimes this does take a moment or so. So we're just going to give this a second. And hopefully by the time I'm done blathering, this will be done. But if not, I'll fast forward it and meet you on the other side. Okay, so everything just completed, all done, as you can see here. So let's take a look at some of the files that we have over here on the left-hand side to understand a little bit of the file structure that was generated as part of this project by default. So we have our source.bat. This is just a file that's used to activate our virtual environment on our Windows machine. If you're on a Mac or Linux, this command will be slightly different, and the precise command that you need to run is located in the readme.md, which maybe that's a good time to talk about this. So if you open up the readme, let me actually make some room for you so you can see a little bit more here. This is a good thing to read if this is your first time kind of running through CDK. And as you can see, like it talks about how to manually activate your environment. One thing to keep in mind is if you close your editor and you come back to this later, you're going to have to rerun the activate command or the source.bat file if you're on Windows to make sure you reactivate your virtual environment, or you may run into problems. But since we just set up our project right here and right now, as part of the bootstrapping process, it also activated our virtual environment for us, so we don't have to worry about it. And you can also like take a look at this and read all about this stuff. There's a bunch of different commands here that you can run, and you don't really need to worry about this right now because I'm going to explain to you pretty much everything here. So you can basically close this out and just listen to my beautiful voice. Okay, so let's close this. The next file that I want to talk about is the requirements.txt. And the requirements.txt, it has two entries by default. You're going to get the AWS CDK lib version 2.9.1 and the constructs here. And this is a change from the previous version, which is CDK version 1. In the previous version, you had to import all of the independent, or the specific rather, AWS resources that you want to work with as part of your project. So for example, if you wanted to use S3, you had to go and find the S3 construct and import that into your project. You wanted to use SQS, you had to do the same thing. And just as a quick little primer, constructs are just kind of these encapsulations of cloud resources. So it could be an SQS queue, it could be a Lambda function, it could be an S3 bucket, it could be a bunch of different things like an S3 bucket and a Lambda function. So that's a higher level abstraction construct. But you by default just get access to some generic ones that AWS provides for you. These are kind of like the building blocks that you'll be using throughout this project. Okay, so that's it for requirements.txt. Now let's take a look at something a little bit more interesting, which is the app.pi file. And the app.pi file is going to tell us, or tell CDK rather, how to construct all the resources that are in this project. And so if we take a look at this line by line, first we're just importing the AWS CDK. Maybe I should just pause here for a second. You can see that this is not importing correctly, and this may cause some autocomplete problems for you. Now, if you're using Visual Studio Code, what you can do to fix this is hold Control and then hold Shift and then press P. And then you'll see here we can Python select interpreter. And I'm going to select Python 3.10 here, which is our global. And we're going to click on this and this should fix itself. There we go. So now we're going to have autocomplete. All that good stuff is going to work. But anyways, so we are importing the AWS CDK. We're importing just basically the stack. And the stack is something that I'm going to get to in a second here when we talk about line 9. But we're also on line 8 here, we're creating a variable called app, and we're initializing that app using the cdk.app function. And so what this does is there's only one app that exists in your entire CDK project, and you're going to be passing this variable around. This just kind of represents your entire application. And not really much else that you need to know about the app object. Now on line 9, we're creating a SQS Lambda demo stack, and we're passing in the app, and then we're also providing a name here. And so SQS-Lambda-demo. Now I didn't type this in. This was just default provided. And the reason that they chose this name is because this was the name of the folder that we are currently located in. So as you can see here, yeah, there. So we're in SQS Lambda demo. So depending on the folder that you're in, it's automatically going to generate a name for you as part of your stack. And you can override this. You can change this to something else. That's totally up to you. One thing to keep in mind is whatever name that you select here, the resources that you create as part of your CDK project will be prepended with this name. So SQS-Lambda-demo in this case. That may be something you want. That may be something you don't want. You can also like delete this if you'd like and just kind of keep it as a blank. I've actually never tried this, if this works or not, but I suppose you can. We're going to leave this as default for now. Anyways, let's talk about the stack because this is an important kind of concept in CDK, something that you need to know about. So a CDK stack is just kind of like a logical grouping, a logical container of a bunch of different resources that are related to one another. And right now we just have one stack, but we can create many, many different stacks and kind of separate the responsibility of different things into these different stacks and then deploy them all at once using, the CDK deploy command, which we'll get to a little bit later. So by default, you just have one stack, but if you want to create another one, you totally could, and then you can, just initialize the constructor here like we're doing. So an example of when you would want to create different stacks. So maybe you have a bunch of kind of database infrastructure, like maybe a DynamoDB table or an RDS database. You can put all that stuff in one stack and then deploy that as part of the database stack. Maybe you also have an application dashboard and you want to create all the stuff that's related to your application dashboard and your maybe alarms. You'd put that in another stack called maybe dashboard alarm stack. Maybe you have an infrastructure stack like SQS and Lambda, like we're doing here. You can create a separate stack for that. So it's a way for you to separate your resources out into these separate groups, and it's very flexible. So you get to pick how you want to group things together, and it's completely up to you. So in this case, we're just going to stick with the one stack here just for demonstration purposes, but you can go nuts with this and try a bunch of other ones as well. And so on line 11, we're calling the synth command, which is basically to generate or synthesize. You can actually hover over this. Yeah, maybe see. So we can synthesize this stage into Cloud Assembly. And this is basically going to generate all of this beautiful CloudFormation template file code that is going to be deployed into the AWS cloud. Don't worry about this yet. We're going to talk about this later when we actually run the CDK synth command or synthesize command to see what it generates. But we'll come back to this a little bit later. All you really need to know is that you got an app, you got a stack, and you synthesize it into some CloudFormation, and CDK worries about the rest. Okay, so that's it for this file here. So let's close this out. I want to go into now this default folder that was created for us. So SQS Lambda demo here. So if we open this sucker up, of course, it's got an init.py. It's also got a, can we do that? There we go. SQS Lambda demo stack.py. And similarly, the name of this folder was pre-selected, or name of this file rather, was pre-selected for us. I didn't pick that. This was just based on, whoa, there's a lot of weird things happening here. This is just based on our folder structure or folder name. And so let's talk about what's happening here, just kind of line by line. So first of all, we're just doing some imports at the top. So we're importing these different constructs. We already talked about briefly what constructs are. We are importing some resources from the AWS CDK dependency library, some variables here that are used for different things that we're creating below. I'm actually going to get rid of IAM. I'm going to get rid of SNS. I'm going to get rid of SNS subscription because we're not going to be using any of that. We're going to be adding some things here a little bit later too. So, I'll come back to this in a second. And so what's going on line 9? So we're defining our SQS Lambda demo stack. And if you recall under our app.pi, if we go here, this is the constructor for SQS Lambda demo stack. So if we wanted to create another stack, we'd create another file that looks very similar to this one and just name it what we want. And then we would add it in the app.pi, maybe infrastructure stack or something like that. Give it a name and it'll also deploy everything that's in that file as well. But anyways, let's take a look at this a little bit closer here to understand. So we got this initialize method passing in some things. You don't need to care about that. Line 12, you also don't need to care about that. This is just all boilerplate stuff that is part of every kind of Python stack. And so what's going on line 14 to 17? So here we are creating a queue, an SQS queue, and we're assigning it to the queue variable. And you can see here that we're using that SQS library and we're calling the queue function. We're passing itself. We're giving it a name, what we want to name this queue. We're also setting some parameters like visibility underscore timeout, which is going to be duration of seconds 300. So 5 minutes here. And so these 4 lines of code, or arguably 1 line of code that you can wrap this in, is going to create a full-fledged SQS queue for us in AWS. And it's also going to provide some sensible defaults for settings that we don't specify. So things like maybe the retry policy or whether or not there's a dead letter queue enabled. All of this is going to be kind of preset for us. Now, if you wanted to override those parameters, you absolutely could. So if you wanted to see a little bit more about SQS queues, Control click on this and you can kind of read through if you really want, all the different settings here that you can specify. So queue name, FIFO, all the different stuff here, DLQ, deduplication, all this kind of stuff. So the nice thing about this is that all this stuff is set to some sensible default for you if you don't choose to specify it. But if you do want to override it, then you're absolutely entitled to do so by just setting the parameter for the corresponding setting. So that's just one example of why CDK is so powerful in general. You can create these pieces of infrastructure with very few lines of code that have sensible defaults. And so we also have a topic here for SNS. This is doing something similar. We're not going to talk about SNS here. I'm actually just going to delete all this stuff. Again, I do encourage you to follow along here. So we're just going to kind of clean this up because following along is the best way to learn. Okay, I also want to show you in the tests folder. And if we go into this and we go into unit and we go into the test file here, so test SQS Lambda demo. And this is also another very powerful feature of using CDK. You can write unit tests for the stacks that you develop. This is a great way to ensure that whatever code that you are writing to create and configure your infrastructure is testable. It's not just going to be some, random paint that you slop at the wall and see if it works correctly. You're going to be able to verify the functionality of the things that you are trying to create in terms of the infrastructure, that is, as part of the development process. And so you can take a look at this. We're just creating some test methods here. We're creating an instance of our app. We're creating a stack here for our SQS Lambda demo stack. There's some special syntax that you need to do in order to unit test with CDK. So we're assigning the template variable template from stack, and we're providing the stack here, which is our demo stack. And then here you can do things like has resource properties. It has a queue with this particular parameter and this particular value. So this notation, you kind of need to know a little bit more about kind of what CDK generates as its output in order to know what value to put in here. But just kind of remember the general structure of this, like AWS : SQS : Q, because later in this video, when I show you when we synthesize our CDK, you're going to see some similar kind of notation in the generated CloudFormation file. So if you wanted to run these tests, then you can just run, I believe it's pi test, just to run these by default. And if I'm not mistaken, there is an entry here in the readme.md. Let's take a look. You can begin exploring the code, blah, blah, blah. There's a very trivial test included that can be run like this. Yeah, so you can just run pi test to run this stuff before you choose to deploy it, which is another great way to verify the integrity of what you're doing so that you're not gonna kind of blow anything up in production or whatever. Anyways, so that is it as part of kind of a gentle introduction to the file structures here. I'm just going to kind of close out some of this stuff. We're going to leave this one open, SQS Lambda demo stack, which is located inside of the SQS Lambda demo folder. So leave this sucker open. I'm going to close out the app.pi. So at this point, we are ready to install some dependencies that we need. Remember, in our requirements.txt, we have the CDK lib here in a constructs folder. We just need to run a simple command to install all this stuff. So let's just clear all this out and get rid of it. And so I'm going to type python-m pip install-r requirements.txt. Hopefully you can hear my beautiful clickety-clacker MX Blue keyboard thing that my wife bought me. But anyways, hopefully it's not too loud for you. So I already pre-ran this command earlier, so it's already kind of pre-installed with all the different requirements here. So for you, it may take a little bit longer, but for me, it was pretty instant. So this is just going to make sure that we don't get any errors when we try to deploy this stuff a little bit later. So you can close out the requirements.txt file. I'm also going to close our terminal out, or maybe just bring it down here so we don't get annoyed by it. And so we're going to start making some changes here to our code so that we can add our different resources, or our Lambda function in particular. So let's go up to the top here. We need to add some other dependencies so that we're going to be able to create our Lambda function. So I'm going to add a separate line here, and we're going to say AWS _ Lambda as Lambda _. Now, why the Lambda _? There's a namespace conflict with Lambda. If you just try to do Lambda, you're going to get an error, as you can see here. So you just need to either prepend or append an underscore, some kind of identifier here in order to make sure this works. Kind of silly, but kind of that's the way the world works. We also need a second import that we require here, and that's going to be for our event source to tie our Lambda function and our SQS queue together. And so for that, we need AWS underscore Lambda. You can actually see the autocomplete here, event sources. And similarly, we're just going to say Lambda underscore event underscore sources. For this one, you don't need to append or prepend with an underscore. There's no naming conflict for this. Okay, so now we have access to the two different extra dependencies that we need. Now we can write some code to actually instantiate an instance of a Lambda function. And it's very simple to do that. But before we do that, I want to write the Lambda handler itself, like the function that's going to exist in the AWS cloud. And so in order to do that, we're going to go back to our project structure here. I'm just going to kind of click out of my folder, and then we're going to click on add folder, and I'm just going to create a new folder. We're going to call it Lambda. And inside of this folder, we're going to create a new file, and we're going to call it lambda underscore handler.py. And so this is going to be the entry point for our Lambda function. So we're going to define a function here that's just going to be our handler. We're going to need some dependencies here. I have it on the side of my screen here. Let me just pull it up so that I remember exactly what I need. Okay, so this is just going to be kind of a very simple demo function. It's not going to like do anything in particular. It's just for demonstration purposes. So just bear with me here. So we're just going to do def handler. This is the main function. And then we're going to pass in an event and context. And as a quick reminder, the event object contains the input to your Lambda function. In our case, it's going to be an SQS message that is invoked as part of our Lambda function. And then the thing that I always suggest as part of creating your Lambda function is to print the event that gets passed in. This is helpful for all sorts of reasons, but particularly debugging when you're setting everything up. So we're just going to print the event. And since we are using SQS as the event source, you do need to return a well-formed HTTP response with a 200 OK or a 500 if you want to throw an error or something like that. So we're just going to return an object here. And so we're going to say status code inside. We're going to say 200. And then we also need to provide a body. And we're just going to say, success or whatever you want. This can be like another object if you want. But for our case, this is more than enough. Okay, Control S to save this, and we can actually close this out. We don't need to come back here, at least for now. And we can proceed with kind of setting up our Lambda function in our CDK code. Okay, so first of all, we already have our queue here on line 16. We're going to just leave this stuff as default. We're not going to mess with it. Just a default visibility timeout is fine. I believe that's actually a required parameter, which is why it's here in the first place. And by the way, if you wanted to give this queue a different name, you can kind of change it here. This is what will show up in the AWS console. So let's create our Lambda function now. So actually, let me give you some comments here so you can see what's going on. So create our queue. And down below, we are going to create our Lambda function. All right, so we are going to create a variable called SQS underscore Lambda, and we're going to assign it to basically what we have here. So we're going to say Lambda underscore, this is our object from up here, or our import rather, and we're going to say dot function. And you need to pass in self, that is the first parameter. And then you need to give it a name. So for us, you can call it whatever you want. I'm going to call it SQS Lambda. And then we need to provide some different inputs as well. And you can see some of them popping up here, but I really don't like that. So I want to actually make some space. Can I fix this? Format feels strange to me. Okay, suppose that's right. Okay, so first thing we need to do is we need to give this function a reference to our Lambda handler that we just created. So we need to tell AWS, or tell CDK rather, where is the code that you want to run as part of this function. And in our case, we just wrote that function. It's right here. It's this is the handler, right? So we need to say, in the Lambda folder, and here's the function name. Basically, we need to tell CDK that so it knows where to find this file and what function to run. Okay, so that's what we need to do as our first step here. So we're going to say handler, is that, yeah, okay, is that right? That looks a little bit off to me. No. There we go. Python is always very finicky with spacing, which is why I'm taking some extra time here. So handler is equal to, now the first thing you need to do is type in the name of the file. So for us, it's lambda underscore handler. And in our case, without the .py or without, Python here. And then the name of the function. So name of function, which is handler. So to recap, lambda underscore handler is the name of our file, lambda underscore handler. And the name of our function is handler, and we're gonna put handler here. Now, keep in mind as well, well, actually, you know what? I'll get to that a little bit later. The next thing we want to do is we want to define our runtime. So for us, we're going to be using Python here. So we're going to say runtime equals lambda underscore dot runtime. And you can see some of the defaults here. So .NET, whatever you want, Java, Go, blah, blah, blah. We're going to say Python 3.10, which is right here. And I just want to pause for a second here to kind of identify something for you, which is that right now we are creating our kind of stack using the Python programming language. However, maybe the language that you want to use to write your actual Lambda function itself, this file here, maybe you want to use TypeScript, maybe you want to use Go, maybe you want to use C# or Java, whatever it may be. You can absolutely do that. So you can put Java file names in here or Go file names and kind of create a handler using that programming language. And all you would need to do is basically the exact same thing, but specify the runtime that you want. So in other words, you can mix and match things together if you, for whatever reason, your organization wants to use a certain language for kind of setting up your stacks and a different language for implementation. You can absolutely do that here. It's a small detail, but an important thing for you to understand as a kind of potential or a kind of possibility when using CDK. So at this point, you're probably wondering, okay, we put in the name of our folder or the name of our file here, we put in the name of our function, but how does it know kind of where it's getting this from, like the folder structure, right? And that's kind of our next step. So we need to tell it kind of where is this stuff, where is the stuff from handler? And so in order to do that, we need to specify in code. So code equals, we're going to say lambda underscore, and then it's code, capital C, by the way, .from underscore assets. And you just give it the name of your folder. So it's just lambda in our case, like we have over here. Looks like I missed something. And yeah, so I think I just missed a period. So there we go. Okay, so that's it for creating our function. Now the next thing that we need to do is create an event source for our function that's going to tie our queue together. So we're gonna create our event source now. And this is also very similar. Let me make some more real estate for you. And so let's say SQS underscore event underscore source is equal to lambda underscore event sources. This is using the import right here that we specified on line 7. And we are going to say .sqs event source. SQS event source using autocomplete now. You can start to see the benefits of using CDK here. Like you get autocomplete. Just a quick little sidebar here. Before CDK existed, we had to write all of our infrastructure using CloudFormation. And CloudFormation is, love it or hate it, it's kind of a little bit verbose, but you didn't get all this autocomplete stuff. So you had to write these like multi-hundred line CloudFormation files, and it didn't tell you anywhere. It didn't give you autocomplete or hints or suggestions in terms of what the parameters are that you need to specify. So you were constantly going into the documentation for CloudFormation, looking up, your Lambda function, whatever it is, finding the entry that you need to put in, putting it in, running your CloudFormation deploy, getting an abstract error that you didn't understand, trying to debug it. It was an absolute nightmare. But you can see how easy it is now. You get all this type hinting as part of using CDK. It just makes your life a million times easier. I'm kind of jealous because you don't have to go through the pain that I had to go through when I was initially learning this stuff. Anyways, so we're done with the event source. By the way, we passed in the queue here, which we created up here. So that's going to give this object a reference to this queue. And now we need to bind our Lambda function to this event source. So that's our final step. So add SQS event source to Lambda. And this is just a one-liner. So we're going to say our Lambda, SQS underscore Lambda dot add underscore event underscore source. And just pass in the SQS event source that we just created on line 30 here. And so just Control S to save. And that's it. So very, very simple, very easy to write this code, and you're going to get like a whole bunch of infrastructure created as a result of it. So that is actually our next step here. So we're going to run through the different CDK commands that we have at our disposal to deploy this and check it out later in the cloud. So I'm going to bring back my terminal here. And I can actually kind of get rid of most of the stuff here because we're just going to be running commands from now on. So there's a bunch of different commands that are at your disposal when you're working with CDK. And I think if you just type CDK, it may just give it to you. Yeah, there's some flags here. There we go. So there's list, synthesize, bootstrap, deploy. There's a bunch of stuff. We're going to talk about a subset of them, the ones that you need to know about. But you can read through the documentation here if you have a little bit more time. Anyways, let's clear this up. So the first thing that we need to do as part of our initial project setup here is we need to run the CDK bootstrap command. And the CDK bootstrap command is just going to initialize some of the different AWS resources that we need as part of this project. And so for us, since we're using a Lambda function here, we are going to, well, not we, but CDK or CloudFormation is going to deploy the code that we wrote into an S3 bucket. And that S3 bucket needs to exist prior to us trying to deploy our CDK app. So by running the bootstrap command, it'll set up all that stuff for us automatically, and also some additional roles and different policies as well. So that's a one-time thing. Once you set up this project, you don't need to do this again. So CDK bootstrap is done. For you, it may kind of show an event log of all the different things that it's creating. So if you see that, if you're running this for the first time, don't be alarmed. I've already ran, I've used CDK a lot, so I don't need to do that again, at least in my case, but you may if this is your first time. Okay, so the next thing that we want to do is run the CDK synth, which is short form for synthesize. And what this is going to do is it's going to look at all the different stacks that we have in our project, and it's going to basically analyze them and output a CloudFormation file. And the CloudFormation file is what is the actual thing that gets uploaded into the AWS cloud. And if you don't know anything about CloudFormation, CloudFormation is a service that allows AWS to deploy a whole bunch of resources on your behalf through a kind of an input template file. And that's what's happening behind the scenes here. CDK isn't really deploying stuff. It is just generating a CloudFormation file that it is passing over to CloudFormation, and then CloudFormation is deploying this stuff. And so that's what's working behind the scenes. So by running this command, CDK will analyze all the stuff that we have in our project over here and then show you what that file looks like. So I'm just going to press enter now, and you're going to see a big confusing output that you may not understand, and that's totally okay, and I'm going to explain it to you. Okay, so this is a YAML file, the output, which is, love it or hate it, YAML is something that you may have to get used to if you're using CDK and CloudFormation, just because it's kind of the default here. And so we're going to scroll up a little bit. You can ignore some of these things. Like some of this is just boilerplate stuff that you don't need to worry about. But let's scroll all the way to where it first starts. There it is. Okay, so what's going on here? So we have this resources kind of key, and inside of it we have this name here, SQS Lambda demo queue. That's familiar. That's what we created in our demo stack, right? And so you can see the type. So this is a type of a queue and the different properties that we have set on it. And if you recall, when we created our stack, if I open this up really quick, I think I gotta just minimize this. Yeah, so you can see SQS Lambda demo queue and SQS Lambda demo queue, so same name. You can see the properties, visibility timeout, which is 300 seconds, what we specified here. And then you also see some extra stuff related to this. So update replace policy, deletion policy, metadata. I didn't set this. How did this get set? And so this is, again, the nice part about using CDK. If you don't provide these things, sensible defaults are provided for you if they are required parameters. So you get all this stuff for free just by using this very simple command here. So let's keep on talking about this file because we have some other stuff here. So we also have our Lambda service role. We don't really need to worry about that. This is the role that our Lambda function is going to use. So we can skip over that. And I want to go down to our actual Lambda function. If we can find it, yeah, there it is. So SQS Lambda. You can see it also has this name appended to it. This is just a randomly generated name. I believe it's for uniqueness, but I don't actually know the reason. And oh, one thing, sorry, before we get to Lambda functions, remember earlier I was talking about in our unit tests, I was telling you to remember the structure of what was there. And I was saying : SQSQ. This is kind of how you know what to put in your unit test. So the type is a queue here. And let's just actually drive back to that really quick. So I'm going to open up our unit test again. Sorry, I'm opening stuff and closing things again and again. So you remember this? This is our unit test here. Template has resource properties AWS SQSQ. AWS SQSQ. So how this test works is that it's basically looking at this file here to make sure that the setting that you specify here is actually present. So this test is testing to ensure that visibility timeout is 300 seconds. Well, I got good news for you. Visibility timeout is 300 seconds. And that's because that's what we specified over here in our Lambda stack. We set this visibility timeout to 300 seconds. Since we're using Python, the name doesn't look exactly the same, but the name of the entry here is correct. So visibility timeout. So that's what's going on here. And that's how unit tests work. Basically, you need to output your file here or run synth and then kind of look at the parameter and then look at the value and make sure that it's present. Okay, let's go back to our Lambda function here because that is worth talking about, of course. So we got our Lambda function. It's a different type, AWS Lambda function, and got the code that it's going to be uploading to S3. So all this code is going to be located in S3 for us, which is great. It's also got some other stuff that it's doing for us. So it's specifying where the handler is, the role that it's going to be using, the runtime, other dependencies. So one other thing to know about CloudFormation is that you can set dependencies. So if other things need to be deployed before this thing, then you can set that up using this syntax here for depends on. By the way, I do recommend learning a little bit about CloudFormation because, you know, love it or hate it, you may run into problems one day, and it's good to know kind of how it works so that you're not just like, what is happening here? So maybe just, I actually have a YouTube video on this. If you want to go to my channel, Be a Better Dev on YouTube, you can type in like CloudFormation introduction to learn a little bit more about this. We're also going to be doing a kind of brief little intro about it here in a few moments once we deploy, but something to be aware of. And we also have the event source mapping, which is kind of tying our Lambda function together with our queue. So it's referencing our function name, and then it's also giving it our event source ARN, which is our queue that we just created. Okay, so that is basically what you need to know as part of the synth step. So one other thing that I did want to call out briefly is that when you run the synth command, if you take a look, I don't know if you noticed this when I was writing it, under the CDK out folder now, if you open this sucker up and you, maybe if I can expand this. Yeah, so if you look at the template.json file, this is, gosh, this is annoying here, isn't it? So this is, you know, there's JSON and there's YAML. They're kind of interchangeable, but this is the same thing that we were just looking at. It's the output of the synthesize command, but they actually save it as a file. And so this is just the JSON representation of it. So it looks pretty much exactly the same. So if you want to take a look at this in a more kind of consistent way, then you can come and take a look at this file here and kind of peruse through it at your kind of liking. But at this point, we are ready to try and deploy all of our stuff into the AWS cloud. So let me bring my terminal back and we are going to run some commands. So clear that out. Now, what we can do now is, before we deploy, one small thing actually that you should know of, there's this command called CDK diff. And what this command does is, and it looks at what you have in your files, in your stack. It looks at what you have in the AWS cloud as part of your CloudFormation stack, and then does a diff for you. So it shows you what is going to change. This is a good kind of pre-flight step to do as part of your development cycle. So you can say, okay, I wrote some code, I changed some things. What is actually going to change in the cloud? It's also useful if you have multiple different developers that are working on one stack at the same time, and maybe someone will do a conflicting change, like they're changing the same resource as you. You'll be able to see that here. So if we just type in CDK diff, press enter, it's going to scan what we have here, scan what we have in our AWS account, and show us a preview of kind of what is going to be changed as part of this. And so this is a lot of green text here, but you can see there's some IAM changes here. So we're gonna, the plus or the green rather is for adds. If there's removes, then it's red, and there's modifies, I believe it's yellow. So we're gonna add some roles here, that's fine. We're gonna change some policies. We're going to add some parameters, and then here are the specific resources that we're creating. So we're creating a queue, we're creating a role, creating a policy, creating a function, creating an event source mapping. So that's kind of how to use the diff command, and it's useful. I use this a lot, so it's useful to know that it exists. So let's clear this out. We're finally ready to deploy everything now into the AWS cloud. Finally, sorry, we took so long, but I wanted to make sure that everything was clear before we got here. So let's go and type CDK deploy now. And hopefully if I didn't screw up anywhere, then all of this stuff should work. And so as part of running this command, you're probably going to see a stream of events take place. Yeah, here we go. So it's starting to stream all the stuff. Okay, actually, pause there. I'm wrong. There is a confirmation step here, and it's an important one because whenever you run the deploy command and there's changes to IAM, it's going to show you here. But do keep in mind, it doesn't show you the diff like we saw when we ran the diff command. It just shows you the stuff that's a change to IAM because that can be, security concerns. So we're just going to type in yes now or Y to confirm. And just to continue my train of thought, this is going to upload this JSON template file into CloudFormation as a change set. It's actually doing this right now. And then that is going to trigger CloudFormation to deploy all of these resources. And that's what this is doing here. So it's showing you, oh, review in progress. It's creating my stack. It's creating my queue. It's creating my roles. All this stuff is being created for me through CDK, and we just have a view into it. And so this is a good way to keep an eye on what is happening in your CloudFormation deployment. And so what I want to do now is bring you into CloudFormation itself, because we are finally ready to see kind of what gets deployed in our AWS account. So let's kind of go into there and just keep in mind like kind of what this looks like. Create in progress, create complete, some of the keywords here, because when we go into CloudFormation, so if you don't know how, you can just type in CloudFormation, by the way, up here to get to where we are, CloudFormation. There you go. So if you click this and then you go to stacks and then you go to refresh, here's our stack, our SQS Lambda demo. And so it's showing create in progress, which is exactly what we have in our code here. So it's still running. And if we go back here, we click into this, we can go to events. Let me make this a little smaller. Okay, that's better. Let's clear this out too. And can we? Yeah, we don't really need what's going on the left. You can see that kind of live stream of things that are happening. So if you just constantly click on refresh, you'll be able to see this in real time as it updates. And so this may take a moment or so because we're creating like 8 or 9 different resources here. We're only specifying 2 or 3, but there's a lot of stuff that's going on behind the scenes. And if you ever run into any errors or there's any kind of problem as part of the deployment, you'll see like an error here. So it'll say like delete or update failed and roll back in progress. So the nice thing about this is that if an error is detected, it'll roll back all those changes for you. So you won't be in like a partial success, partial failure case where some stuff is there, some stuff isn't. It will roll back all the stuff that it was trying to do. So you're left with a clean slate of where you started from. And so this shouldn't take too long. And okay, so that's complete. Let me refresh the stacks on the side here. So yeah, now you can see it's create complete as well. So everything was created. So at this point, everything is there. Our Lambda function is there in our AWS account. Our event source is there. Our queue is there. So how do we actually find this stuff? One way is to go into the different sections of the console and go and look around, and you can absolutely do that and you can find it that way. Another way is to go to resources here as part of your stack. And for some resources, it gives you a hyperlink to it, which is what I want to show you. So for our demo queue, you can click on that. You can see this one does not give you a hyperlink, which is kind of annoying. I don't know why it works like this, but you can see for our SQS Lambda, this does give you a hyperlink. So this is our event source too, which similarly does not. So if you click on this, this is going to bring us to our Lambda function now. So here is our Lambda function that we just created as part of our setup. And you can see that it has a trigger. It has an event source of SQS. If you click on this, scroll down, this is the SQS Lambda demo, the queue that we just created. And so let me open this up in a new tab. We're going to come back to this in a second. Let's finish talking about Lambda first though. If we go to our code and you take a look at this, this is exactly what we wrote in one of the previous steps, right? We created our handler, we printed the event, and we're returning our 200 with the body being success. So all that stuff that we wrote in Visual Studio Code is now present here in our Lambda function. So this is awesome, right? And so let's talk about the queue now. So the queue also got created, right? So it's also over here. And so this brought us directly to it, but if you want to see it yourself, you can just go to queues, and then here's our queue. So we click on this sucker. And if you look at under Lambda triggers here, you can see here is our Lambda triggers. So the queue is triggered by the Lambda. And so here's the kind of entry for that. This is the event source mapping that we were talking about. And so what I want to do now is just prove to you that all this stuff is working. So let's try and publish a message into this queue and see if it gets picked up by our Lambda function. So we're going to go to send and receive. We're going to type in hello for message 1. That got sent. We're going to put world for message 2, and then a couple exclamation points for good measure. So let's click on that. And so now let's go back to our Lambda function over here, and we're going to go to monitor. And one thing to know about, I believe I talked about this earlier, but the metrics for Lambda are only collected every couple minutes or so. So you're not going to see any metrics here yet, but the logs are collected near instantaneously. So if you go to view CloudWatch logs, this is going to bring us to the log streams for this function. And if we click on the first entry that should be present here, which is right here, we should be able to see the function logs as part of the processing. So you can see start request, start request, start request. That means there's 3 messages or 3 invocations of this function. And if we expand this out, this is kind of the print event, which I told you in the beginning is always a good idea. Always print your event, the first line of your Lambda function code. You can see what is inside. So it's this object here. And if you look a little bit closely, we should be able to find the body. Yes, so body, hello. And if we look at the other ones, there should be world, there's world. And if we look at the last one, it should be exclamation points. And one thing to keep in mind is when you're using SQS and Lambda in general is that it comes in as you can potentially process multiple messages at once. Right now, we're only doing one at a time. So it's an array here. So it's records and there's an array. So if you processed multiple messages or you kind of configure your queue in your Lambda to pick up multiple messages at once, you need to access them by index or iterate over this records object here. So you would do something like, let's go back here for a sec. I'll show you what you'd probably have to do. You would need to, if you want to get like the specific message, you would do print events and then records. So we're getting the records array and then 0 for the first one. And then if you want to get the body, you would do this, right? And so you can also just iterate over everything in records if you want to do this in a cleaner way and then just pull out the body and process the message, yada, yada, yada. But remember, you should never modify the code in the console. If you are using CDK, you are making a commitment that you are not going to modify stuff in the console. You're going to use CDK at all times. This can introduce a phenomenon called cloudformation drift, which is an absolute nightmare to deal with. It results in when there's an inconsistency between your code and what you have in the cloud, which is just a pain in the butt to unwind. So just take it from my pain that I've experienced in a past life and don't do it. So that's a primer here for using CDK. And one thing that I wanted to show you before we get going, or I let you go, is how to delete all this stuff, because maybe you don't want to have this stuff sticking around. So we're going to go back to our editor here, and you can just type in the command CDK destroy. And what this is going to do is basically delete everything from your stack and just leave you with a clean slate so that you can kind of move on to your next project. So hopefully you enjoyed this video and learned a lot about CDK. Thank you so much, and I'll see you in the next one.